You guys can hear me?
I can hear you.
Yeah, great. Great. I guess I've been share my screen.
So if we just have the app open, it'll show us your screen.
Yeah, so yeah, if you have the app open, you should be able. Can you see me? Can you see the notes or?
Yeah, I can see you.
All right, great, great guys.
Good morning, Amon. How are you?
Good morning, Nick. Good on you.
I'm okay. Just was doing a little bit of balancing an empirical formula last night, but I was still getting a little bit confused.
Okay. Do you have a specific question on that?
On empirical formula, yes, I do. I'm looking at your multiple choice worksheet right now. Can you explain either number 1 or number 2? Because either one of those.
Okay. Let me open my. All right. So you were saying on the multiple choice, right?
Yes.
For which one again?
Either number 1 or number 2.
For which worksheet? Empirical formula?
Yes.
So these ones?
Mm-hmm. Yes.
So how to go from percent? And find the empirical formula. So what do you got to do for all these? Did you start these problems?
Yeah, I started them.
Where are you stuck?
Because what I did was I divided the sulfur by the molar mass, same with each one, but I'm trying to figure out what I do after I find the molar masses of each one, or divide them by the molar masses, I should say.
Yeah, you get the moles and then the smallest whole number ratio. So you divide by the smallest mole that you're gonna get. So for sulfur, why is this not writing? So sulfur, you're gonna see 27 grams, right?
Yeah.
And then oxygen is 13.4. Again, we have just assumed that we have a total mass of 100 grams, and that's why all these percentages have become grams. For chlorine, it's 59.6 grams. You do it by each molar mass. What's the molar mass of sulfur?
Molar mass of sulfur is 32.066.
For oxygen, it's 16. For chlorine, what is it? 35 what?
35.453.
35.453. Then you'll get the moles for each one.
Okay.
Did you solve these already?
Yeah.
Yeah, what did you get when you divide?
Well, I got 32. Let's see what I got.
0.842.
Exactly, yeah, I got that. And then for the next one, I got 0.84 and
0.4 what?
0.84 I got for oxygen.
Okay, I got 8375.
Well, that's what I actually got. I just rounded it.
Yeah. Chlorine, it's 59.6 divided by 34.45.
Which I got 1.68 actually.
Yeah. So now you pick the smallest number and then you just divide them by that.
Okay, so I just divide all three by that small number.
Yeah. So what you'll do is just divide by 0.8375, 0.8375. And I think S should be 1, O should be 1, and chlorine should be 2, I think. 1.
Yeah.
Yeah, so that's it. That's the answer then.
So would you say I got it so far? I just need to just pay attention to what I'm doing?
I think you already knew how to do did you already do the last few questions on this worksheet? Because I think you did work on them already last time.
I worked on some of them actually, but the one I actually did in the lab was actually moles in the stoichiometry worksheet.
Yeah.
Just the empirical.
Answer.
All right.
So that makes sense. Yep.
I have a
Yes,
question
Stephen. Uh-huh.
on exercise. It's the stoichiometry problem.
First, so stoichiometry multiple choice.
No, it's a exercise G, number A5.
Exercise G A5. Okay.
On the key, it said like to skip it or something.
Yeah. So thing is, if you download it again, there's an updated version
Uh-huh.
which actually has the answer.
Oh, okay.
Okay. So that key that I uploaded was actually for the intro chemistry for the CHEM 100 because
Gotcha.
I teach that as well,
Okay.
and I mistakenly put that here on your class. So now I changed it.
Okay.
But this should be very much like a usual stoichiometry question.
I couldn't figure out. So PB, so lead nitrate, right?
Uh-huh.
Is the excess reactant?
Yes. So if you look at the reaction, if we label everything, so the first is 30 grams of NH4 3PO4. This is this first guy, right, on the chemical equation.
Yeah.
And then it says with excess PbNO32.
Okay.
When they use this word excess, they just mean don't worry about it. That's what they mean. So they're
Okay.
saying it's not a limiting reactant. That's what basically they're trying to say.
Okay.
That we have enough of it.
So you just take so you're looking for, so you use the 30 grams
Of ammonium phosphate
ammonium phosphate.
and change it to, see, the question is then talking about 3 grams of Pb3PO42 lead phosphate,
So
which
you
is
change
this
it to
guy at the end.
that.
Yes, you change it to this guy.
Okay.
Yeah, and then that will give you the theoretical yield, right?
So I did that, and my theoretical yield, I'm not sure if I did it right. It said it was 99.968 grams.
So I think I have the key. Let me quickly open the key. If I have the right one, G, right? Yeah, this one here, right?
Oh, that is there. Okay.
Did you get, you were saying 99?
99. I probably just added it wrong. Oh, no, actually, I did get 81.64. Sorry, my paper's wrong.
Oh, okay. So your percent yield will be then 3 grams, which was produced actual
Okay.
over theoretical times 100. So your final answer is 3.67. You
Okay,
get
that
that
makes
as
a lot of
well?
sense. I was just confused because I didn't expect it to be such a low percent.
Yeah, no, this is a weird number. I will agree.
Okay.
The actual yield is very, very small.
Yeah.
Yeah, you're right.
Will it usually be like that, or it doesn't matter? I just have to pay attention.
I mean, it actually doesn't matter. I mean,
Okay.
if you're going right with the numbers, see, it is possible to get a low yield. Maybe the reaction is so complicated, maybe the procedure is so complex that the yield is very low. So that is possible.
Okay.
But if you get weird number like that, I will still double check, because when I also got that, I double checked everything that all my motor masses are correct, my setup is correct, because that's a weird number, very
Yeah.
small number. Yeah.
Okay.
And
Thank
then
you.
also I posted the last one if you want to check that. Okay.
Yeah. Cool.
So when you go to modules, you'll find this key.
On the bottom.
Yeah.
Like the
So
last one.
because if you see exercise G, I had asked students to skip for both of them the fifth question on both the pages.
Okay.
But then now I posted the updated one, which has both of them in
Okay.
there
Cool.
in the key. Because if you have the old key, it's also going to say on the next page, it will say skip.
Same
Or
thing.
the next page. Yeah, yeah. So don't skip. You do that problem as well.
Gotcha. Okay.
Any other question?
So the answer for that one was 86.1%, or what was it? Because that's what I got for that problem.
For which one? First?
The one, yeah, the one you were just saying.
How much did you get?
81. I got something similar to that, except I got 86.1. I don't know if my math was wrong or what I did wrong.
Yeah, maybe you want to double check with the key.
Okay.
So 81, that's not the percent, that's the theoretical yield. Percent is
Right.
actually only 3.67%.
Okay. Yeah, because that's the theoretical yield, and I just divide it by that basically and multiply it out by 100, right?
Yeah.
Okay.
I had some more questions if
Sure.
Nick doesn't have any more.
You guys will go one after the other. So
Okay.
maybe you guys have common questions, or yeah. Is your question on the same exercise or
No, mine was going to be on molarity and titration.
molarity? Sure. On what exercise or worksheet?
On the
Question desktop question.
multiple choice sheet.
Multiple choice. On the molarity one.
Yeah. Well, it says yeah. That's it. Right there.
Okay. What question number?
Sorry, I had to find. So number 7.
Number 7.
Yeah.
So it says can be prepared by. Okay. So these are the questions I mentioned in the class that you guys can skip for right now.
Oh, okay.
From question number 6, 7, 8, 9, 10. I mean,
Okay.
they're super simple questions, okay? But I did not cover M1V1 equals M2V2. That's the only reason why I'm asking students to skip it. But actually, some part of it you can actually do. So what it's trying
Okay.
to say is that 0.355 molarity solution is what you're going to prepare, okay? You're given 5 different options.
Okay.
Only one of them is correct. Only one of them is the one that's going to lead you to make 0.355 molar K2SO4. So what you have to do is start from A and see if you do the dilution for the first one, what's going to happen, what will be the new molarity. You can actually work on B and C if you want, because those are the ones that, again, they're all dilution. They all use an equation called M1V1, M2V2, but again, this is not going to be on your test. Anything related to dilution will not be on the test. So it uses this equation, M1V1, M2V2. This is like the molarity before and volume before dilution, and molarity after dilution, and volume after dilution. But again, I did not cover it, okay? So don't worry about it right now.
Oh,
So what I'll say is for molarity, you can skip question 6, 7, 8, 9, 10. But then
7, 8.
start again on 11.
Oh, okay.
11, 12, 13, 14, 15, that again you should know.
Okay.
Okay.
Makes sense. Yeah.
So anywhere we see dilution going on, maybe skip that, okay?
Okay.
Yeah. Anything else on this worksheet?
Yeah.
Yeah.
Can you do number 15?
Number 15. So which of the following require largest volume of 0.1 molar sodium hydroxide for neutralization? So this is asking you which one will require most volume if you had a 0.1 molar sodium hydroxide NaOH, and you're given all these options. So you actually have to solve each one and then see which one is most concentrated acid. So if we try to work on this, we have to do each one by one. You'll have to write the chemical equation. So it says the first option is again question number 15 on your molarity.
Okay.
So first option is 10 mLs of 0.5 molar. What is phosphoric acid? H3PO4. So if you try to change this into moles, that's how we'll figure out how many moles of NaOH we need. And for one which we need maximum amounts of NaOH, that's the one which is going to need largest volume of NaOH to neutralize. Does the question and process make sense?
Yes.
Okay. So if we start with this mLs and we change it to liters, it's going to be 0.01 liters. And you are given molarity. So liters here, moles here of H3PO4. And I have 0.5 moles in every 1 liter. That's coming from molarity. So what do I get here is actually we can do one more step and actually change it to moles of NaOH. Let's see how to do that. For that, we need a balance equation. So if this is moles of H3PO4 in the bottom, because we're going to cancel them, and put moles of NaOH on the top. What is our mole to mole ratio for NaOH and H3PO4? Can you guys tell? If H3PO4 reacts with NaOH and it gives you water, and Na3PO4, this is the chemical equation we talked about in the class when you combine acid, and base. Remember, you can exchange the partner. So hydrogen will take the OH, and that's why water is there. And
Mhm.
Na takes PO4, that's why Na3PO4 is made. If you balance the equation, I'll put a 3 here and 3 in front of water, and you'll see this is balanced. Now, what I did is, you can balance this the normal way that you guys have learned in the class, or I can give you a trick. A trick is, if you see your acid has 3 hydrogens, you see this acid has 3 hydrogens,
Mhm.
it's gonna take 3 sodium hydroxide and it will make 3 waters. And now you can actually go and double check that each one is balanced.
So
Right.
anytime you have H3 combining with sodium hydroxide, it'll make.
Right, you're gonna need 3 of
Yeah.
it if the acid has 3 hydrogens.
Okay.
We'll see other examples where there are different formulas, and you'll see how that works out.
Okay.
Okay. All right. So what is the mole-to-mole ratio between H3PO4 and NaOH?
3 to 1.
3 to 1. Okay. So we for 3 sodium hydroxide, 1 H3PO4. So if you guys solve this, what do you guys get? Can somebody put this into calculator?
Yeah, I'll do that right now.
I think it's 0.
0.5. Yeah, 0.015
0.015.
Yeah, exactly. I got that too.
NaOH, right?
Mhm.
Okay, so this first one needs that many moles of NaOH. We'll go to the next option and see how much does that need, okay? So the next question says 20 mLs of 0.05 nitric acid, 20 mLs of 0.05, 20 mLs of 0.05 molar nitric. What is nitric acid, guys?
It's H2NO3 or H3NO3.
No, just HNO3.
HNO3.
How do we know, guys? Nitric acid coming from nitrate. Nitrate is NO3 -1. That's it. So if you add an H plus to this guy, it becomes HNO3. It would be H2NO3 if NO3 was -2.
Okay.
If it's -1, that's why it's HNO3. Right? Right, so we'll do the same thing here. We'll change it to liters, 0.02 liters. Go from liters to moles of HNO3. We can use this number, 0.05 moles in every 1 liter. And then we'll go from moles of HNO3 to the moles of NaOH. Because again, the question is always saying that how much sodium hydroxide we need, right? That's why we're changing it to sodium hydroxide. So what's the mole-to-mole ratio, guys? Can you tell? HNO3 reacted with NaOH. The tip that I gave you guys, try to use that here.
So it's going to be
how many
3 to, sorry.
How many hydrogens are in HNO3?
Oh, just one.
Just one. So what should I put here?
Just one?
Just one, yes. How many waters are we going to make? Just one. And you can actually double check this. I mean, I just gave you that tip, but still, if you wanted to balance this yourself, you can see it's already balanced.
Oh, so the number of hydrogens with the first acid will
is
give
going
you
to decide. Right. Okay. Because you see, for one H, we need one OH to make one water. That's where it's coming from.
Okay.
You see, one H needs one OH to make one water. If there were two H here, it's going to need two NaOH to make two waters. Okay. Does that make sense?
On this one, I tried solving it, but I stopped at like moles of H plus. Is that okay, or should I go all the way through?
Moles of H plus, that's totally fine. You can stop at moles, because moles of H plus will also tell you that how many moles of NaOH you need. Because see, moles of H plus to moles of NaOH is 1-to-1 ratio.
Oh, okay.
That's why even if you're skipping that NaOH step, it's not going to change the number because it's 1-to-1 ratio.
Still get the right answer. Okay.
You still get the right answer. Yes. Cool. So again, the ratio is 1-to-1. So when you solve this, you get 0.010. Right? that what you guys get?
Yeah.
Okay. Then if we do part C says 5 mLs of 0.01 molar H2SO4. 0.01 molar H2SO4. It says sulfuric acid. We should know sulfuric acid is H2SO4, okay? So 5 mLs, that means it's 0.005 liters. Liters to moles. Is it making sense what I'm doing here?
Mm-hmm.
A little bit, yeah.
Nick?
A little bit.
What is not making sense?
Well, where I get stuck at, like, when I'm doing these problems is, like, balancing out, like, the equations. Like, how would you know how to balance them out?
So that's the tip that I was giving you. See, let's say let's balance this one, the next one, okay? So you have H2SO4
Mhm.
reacting with sodium hydroxide. Can you tell me what products will be made here, Nick?
Wouldn't one of them be H2O?
Right, H2O, and what else?
Sodium phosphate?
There's no phosphate, sulfate, right?
Sulfate, yeah, that's one of the.
So what was the formula of sodium sulfate? Is it just this? Is that right?
No,
What's wrong?
they're not balanced. Those aren't
I mean
those charges.
yeah. So
Charges in that.
what should be the formula then?
Na3.
Na2, not
Na2.
3. Why?
Okay.
Because
The
sulfate
eight
is -2.
is Na2, -2. That's right.
That's why it's Na2SO4, okay?
Okay.
Right, now let's balance this. You can balance this like the normal way, like the longer method, but I gave you guys a tip. This only works for acid and base, okay? Nothing else.
Okay.
The trick is, you see how many hydrogens does the acid have?
No, I don't see anything.
No, H2SO4. This is the acid, right?
Yeah,
How many hydrogens does it have?
2.
2. If you have 2 hydrogens on an acid, and it's reacting with sodium hydroxide,
Right.
it is going to need 2 sodium hydroxide,
Mm-hmm.
and it is going to make 2 waters. And just by
Right.
doing this, you can actually double check now that your reaction is balanced.
Mm-hmm.
This trick only works for acid and base. Okay.
Okay.
If you're balancing something else, you gotta practice more balancing on different types of questions. Okay. Or if you want to just do this one again, okay, we'll do this one with the regular way we learned in the class. So now if you want to balance this, what will you see? Okay, tell me how many hydrogens on the left hand side?
2.
2 plus 1, right?
Yeah.
There's also 1 here. On the right hand side it's 2. How many SO4?
There's 4, right?
How many SO4?
There's 1 on the left side.
And
1 on the right side.
okay, and then sodiums. How many on the left side?
1.
On the right side?
2.
Okay. Anything else left? We have the oxygens. This oxygen, 1 oxygen.
Okay.
On the right hand side, 1 oxygen. I'm not including SO4 because we already did that, right?
Okay, right.
Okay. So hydrogen we have 2 plus 1 and then 2 on the right hand side. We have SO4. We'll start with the easiest one. Sodium is 1 and 2.
Yeah.
Okay. So what should I do here, Nick?
You need to put a 2 there.
2 here, right? So that changes this to 2.
Right.
Does that change anything else?
Doesn't it? Well, no, because the sodium already on the right side is already 2, and that's what you want to match.
Yes. But when I put a 2 here in the front, Nick, does that change anything else? Does that affect O and H?
I don't think so.
It does. See, there's this 1 NaOH, right?
Yeah.
If I put a 2 here, I'm saying that I have 2 sodium hydroxides.
Right.
I have NaOH and I have another NaOH. So you see now I have 2 sodiums,
Yeah.
2 oxygens, and 2 hydrogens. So when you put 2 in the front, you didn't only change sodium, but you also changed this oxygen to 2, and you changed that hydrogen also to 2.
To 2. Okay.
Okay? So now you want to balance your hydrogens. You got 4 on left hand side. You got 2 on the right hand side. What should I do here?
Put a 4.
Put what? 4 or 2?
Put a
I
2.
have 4 on the left hand side. Yes, and I want to make this number also 4. So I'll put a 2, and that will make this.
Yeah,
4.
because of the
Because of
2
this 2 in the
hydrogens, you
bottom.
multiply that by 2, right?
Right, right. And you see when you put this 2, it also changes this oxygen.
Yeah.
So this becomes 2.
Makes
so
that
now
oxygen
everything is
2,
balanced.
right?
Yeah.
Okay.
So again, 2 ways of balancing this. Okay.
Okay.
All right. Going back to your 0.01 moles of H2SO4 in 1 liter, and then we're going to go from moles of H2SO4 to moles of NaOH. What's the mole-to-mole ratio, Nick? Can you tell me mole-to-mole ratio between H2SO4 and NaOH?
H2SO4.
Yeah.
NaOH. Isn't that 3 on top? Right?
So look
Moles
here.
of NaOH. No, it's 1. Moles of NaOH is 1.
Where are you looking? No, you're looking at the wrong reaction. Here.
Oh,
You're looking at this one.
okay. Oh, okay. Moles of NaOH is 2 then.
And then H2SO4 is just 1, right? So when you now solve the whole thing, what do you
Right.
get?
0.1.
0.1. Okay. So we have done first 3 so far. You're going to be doing the same way the other ones? Is it 0.1 or 0.01?
I think it's probably 0.01.
0.01, yeah. 0.01 moles of NaOH. So for A, B, and C, can you tell me which one needs the maximum moles of NaOH? So first one needs 0.015. Second one needs 0.01. Third one also needs 0.01. So far, first one needs maximum NaOH, right?
Yeah.
So if you check our option, actually the answer is A. But of course, if it's on the exam, you don't know the answer, then you'll do this one as well. You'll do the last one as well. And then at the end, you will realize that the first one has the maximum moles.
Gotcha.
Right?
Right.
Right. Okay.
Now for each answer you balanced out an equation, right? Aman?
Yes, for each one. For all 5 of them, you'll balance out. Yes. It'll be too repetitive. That's why I'm not doing D&E right now, so I can take more questions from students. But that's how you're going to do it.
Okay.
Okay.
Cool.
Yeah. So guys, ask me more questions. Oh, I see there. Is this mass percent composition? Yeah, molarity. Cool. I guess anything else? Any other worksheet?
Yeah, I do, but I want to make sure the other person asks questions first before me.
Yeah. So Steven, Alicia, do you have questions? There are more people.
I do, but I already asked 2, so if somebody else has one.
If somebody else has a question, or we'll go back to Steven and
She just typed one, I think.
she did.
Yeah.
All right. Can you do example of mass percent? Sure. We did one. I'll go to the. No, that was actually empirical. Mass percent composition. Do we have them here?
Which worksheet is this?
Yeah, I'm also figuring out. Do you guys know which worksheet has a question on mass percent composition?
I think some of the exercises do, don't they?
I don't remember exactly. So, Alicia, do you have a question that you want me to work on? Here we got this one here. So there's one question here. So the question is saying calculate the percent composition of mass of each element in magnesium sulfate. So I'm doing exercise D, question number 4. So it says find the percent composition of magnesium sulfate. So guys, first thing is, what is magnesium sulfate?
Isn't it Mg? Magnesium's Mg and sulfate.
Don't jump to the answer.
Okay.
Do the steps. So magnesium is Mg, you're right. And then what is sulfate?
Sulfate, it is SO4 -2.
What is magnesium's charge?
Isn't it +2?
+2,
Yeah.
right.
Yeah, right.
So when I make the formula, what will be that formula if you do the crisscross or you see +2 -2?
It's just MgSO4.
Mhm.
Just MgSO4, right. So the question is saying, so Alicia, Steven, okay, so you guys are supposed, okay. So we're going to find it for MgSO4, right? So the question is, for MgSO4, find the percent composition. Find percent composition. By percent composition, again, the meaning of the question is, it's saying that Mg has how much weightage in the whole formula of MgSO4. That's what it actually means. Then sulfur has how much weightage, and then oxygen has how much weightage out of the whole thing. So it's saying Mg is contributing how much mass to the whole thing, sulfur is contributing how much to the whole mass, oxygen is contributing how much to the whole mass. So first of all, we need to know the total mass. Where do you get the total mass from?
Periodic table.
Periodic table. So it's the molar mass of MgSO4. So guys, can somebody quickly find the molar mass of MgSO4?
I
It's
got
one-
120.367. That's what I got.
So what do you also got, Steven?
Yeah, I got 120.38.
38. Okay, so that's close. Okay, so we'll go with this number, 120.367. And then magnesium is how much out of that? Magnesium is
24.305.
sorry, say it again.
24.305.
31.
So 305 or 31, whichever you guys gonna go with. And then for sulfur,
32.07.
okay, and then for oxygen,
64.
64. Now you guys can see we're doing it for 4 oxygens, right?
Mm-hmm.
Okay, because our job is not to get just the atomic mass. Our job is to get the total contribution of oxygen for the whole thing, right? So
Right.
MgSO4 is, so this is the total, and these are the individual masses. So for Mg, if you want to find the percent composition, you're going to take the mass of Mg divided by the total mass, 120.367 times 100. So you're going to do the same thing for S and then 4 oxygens. So guys, divide that. What do you guys get? 24 divided by 120 times 100. I mean, the whole
So 20.19.
20.19%.
Yes.
So Alicia, can you hear us? 20.19, that's the percent that you get. All right. So yes. So Mg is that much percent. Then you do the same thing for sulfur, same thing for 4 oxygen. Sulfur is 32.07 over 120.367 times 100. So what do you guys get when you do that?
Oh, which one? That one?
Yeah, 32.07 over 120.
I got 26.64% of sulfur.
26.64. So that's what will go here. And for oxygen, it is 64 over total 120.367. The only mistake that you guys can do here is for oxygen that you just take 16. It's not 16. It's the mass of the all 4 oxygens. So total, and then what's the percent, guys, for oxygen?
53.19.
53.19%. So that's your answer for oxygen, 53.19%. So when you total, this should be very close to 100. It may not always be 100 because we're rounding off and molar masses are different, but it should be close, which I think it is. This is like almost 47%, and that's 53%.
So it'll
Yeah.
never matter if we use like 15.99 for the.
Yeah. See, the thing is, on multiple choice or free response question, if it's a multiple choice question, my options will not be very close to each other. So if I'll ask you, okay, tell me what is the percent composition of oxygen in MgSO4, if one of the correct option is 53.19%, the other options will be like 20%, 20, 30%,
Okay.
and then 70%. So that kind of differences are not going to come from you rounding off incorrectly.
Okay.
Okay. All right, let's
What
see.
about for the mass of like elements like lead? See how it's like 207.2. Like, will we ever find periodic tables that say different masses for that?
Yeah, I mean, maybe so always go with the product table that's given on the test.
Okay.
I mean, maybe the other one is going to say 207.21, or maybe there's a one that says 207.19, maybe.
Yeah.
Yeah.
Okay.
So it's just safest to go with what the product table you have says.
What you gave us. Okay.
Right. Right. Any more questions, guys?
Yeah, I got one.
Uh-huh.
Can you do number 4 on the balancing equations multiple choice worksheet?
Okay. Number 4?
Yes.
Yeah, you should now be able to do this. We just did that.
Yeah. I just did that one too, but I'm just trying to check to see what I've been doing wrong because I'm getting like the subscripts part, but it's just like putting like the coefficients. That's where I'm getting confused.
Right. So Nick, if you're listening to when we were covering the last question that you asked, the number 15 on the molarity question, it was the exact same reaction, right? Phosphoric acid with sodium hydroxide gives you sodium phosphate and water.
Mm-hmm.
What was the tip that I gave you guys? It's only going to work with this one. So what was the tip that I gave you?
Check
the number of hydrogens.
Check the number of hydrogens in the acid, right? This is the acid.
Yeah.
How many hydrogen does it have?
3.
So how many sodium hydroxide are you going to need?
3.
3. How many waters are you going to make?
3.
3. Yeah. So you got that. So it's saying the coefficient of H3PO4 is going to be how much? We didn't even change it, so it's going to be 1. So 1 H3PO4 needs 3 sodium hydroxide, gives 1 sodium phosphate, and gives 3 waters. So it's asking for H3PO4. It just stayed 1. We didn't do it.
So you'll never have to change the acid.
Yes. Yeah, you'll never have to change acid. Unless this was not sodium hydroxide, but maybe aluminum hydroxide, because aluminum hydroxide is AlOH3.
Okay.
That problem, okay? So let's say we have HNO3 reacting with AlOH3, and that gives me AlNO3 plus water. So guys, when you're balancing equations like this one, then don't use the trick that I gave you. I mean, you can, but I will say just skip it and just balance this like a regular chemical equation.
Okay.
So let's do it that way. So we got to look at our hydrogens. We got to look at the only tip that I can give you guys here is if your polyatomic ion stays the same on left and right, then don't break it into individual atoms. Okay. Aluminum left and right, and then we have oxygen left and right. So now let's make a list of how many H do we have on the left hand side?
1.
We have 1 here, and then we also have this one, right? See, this one we got to split. Why do we have to split this polyatomic ion? Why are we not keeping like NO3? Because NO3 stayed NO3, but did OH stayed OH on right hand side?
It did technically,
but you're writing it as water, right? It stayed as HOH, but we're writing it as H2O. So we'll just to not confuse ourselves, we'll keep it separate. So we have 1 hydrogen here, and then we have 3 hydrogens here. So 1 plus 3. And hydrogens on the right hand side are how many?
2.
NO3, how many on left hand side? 1.
Yeah.
How many on right hand side? 3. How many aluminums on the left hand side? Just one. On right hand side, just one. And then oxygens, we have NO3. I'm not going to count because we're already counting NO3. So oxygens here, we have 3. On the right hand side, we have how many?
1.
1. So now you can, I would always recommend you to start balancing with the easiest one first. Aluminum is already balanced, so I'm not going to touch that. It's already balanced. NO3, you can see 3 and 1. So what should I do on the left hand side?
Put a 3 in front of the acid.
Yes. So Nick, where should I put the 3? In front of
in front
here?
of yes, I was about to say in front of the HNO3.
Right. So 3 HNO3. So NO3 becomes what?
NO3 becomes.
When I put 3 in the front, HNO3 becomes 3. There are 3 NO3 sitting inside.
Yeah.
And that also changes this hydrogen, right?
Yeah, exactly.
So I got to change this to 3. Does that make sense?
Mm-hmm. Yeah.
Okay. Now we got NO3 are balanced. Hydrogen, we got 3 plus 3, 6. And then we got 2 on right hand side. What can we do to balance our hydrogen?
Don't you have to make the hydrogen into a 6 also?
Right. So how do I change this into a 6? How do I change this into a 6? If I want to make this 6, how do I do that?
2 times 3.
2 times 3. So where should I put 3?
3, wouldn't that go in front of
it's on the
H2O?
Right. 3H2O. When you put 3H2O here, it becomes 6 hydrogens. What happens to that oxygen?
It goes up.
Goes up to what? 3, right?
Yeah.
That means this also went up to 3. So now you can see it's balanced. Right?
Yeah.
3, 3, 1, 1, 3, 3, 6, and 6.
Mm-hmm.
Okay. So here, what you could have done is, you see aluminum hydroxide was 3, and HNO3 was just 1 hydrogen. So here we need a 3 and mix 3 waters.
Right.
Okay. So again, just to be consistent, you can always just use this method. Some students actually don't like this method. They just want to see. There's 1 NO3 here, so 1 NO and 3 over here. I'll need 3 here, so they'll put a 3 here. Some students like that method more because this can sometimes be confusing. Sometimes students don't like. I mean, it depends on students to students which methods they like more.
When you're balancing a combustion equation, you start with carbon first?
Yeah, I mean, yeah, I would start with carbon or hydrogen, but yeah, it'll be a good idea to just start with carbon.
Oh, that's right. You just do oxygen last.
Just do oxygen at the last. Yeah, that's what matters.
Okay. I have a question on titration if nobody else had one.
Sure. So molarity titration, multiple choice or
yeah, the molarity. Yep, exactly. Number 5 on the multiple choice worksheet.
So do you still want to find the iron 2 phosphate?
Oh yeah, we can do that first. I think that's the other Stephen.
Oh, okay. Oh, that's
that's what I'm seeing here too. Actually, yeah, he wants to find that.
So Stephen, you want to do percent composition of iron 2 phosphate? So iron 2 phosphate. So if you want to find the percent composition, we first should be able to find the formula. That's actually what is more important here, is to go from name to the formula. So iron 2 phosphate, Fe is iron, and phosphate is PO4 -3. What is the charge on Fe? Do we know the charge on Fe?
Yeah, positive 3.
Positive what?
3.
Where do you get that from?
I got that from the periodic table.
No. Iron will not tell you, periodic table will not tell you the oxidation state of iron.
Well, the way I thought about it was that since you have a -3 on that side, doesn't that side have to be positive 3 as well? Or no?
Right, but in the name, are you not given what it is?
No, you're given 2 though.
Yeah, what is that?
Iron 2 phosphate. So that's a positive 2 charge.
Positive 2 charge, right. So if we do the crisscross, what will be our formula?
Fe3 PO4 2
parentheses and 2, right?
Yeah.
So if you want to find the percent composition, then our Fe, we need to find percent composition. For phosphorus, we'll find percent composition. For oxygen, we'll find percent composition. For individual atom, okay? That's how it has to be done. So first, guys, you tell me the molar mass of the whole thing.
Steven says he got it. He just needs the formula.
Oh, you just need the formula. Okay, never mind. Because we have done problem like this before. Also, Steven, if you go back to your, if you go back to the video and I'll post this on YouTube, you should be able to see similar problems that we did. Right. So going back to the molarity titration question, because we don't have much time left.
Yeah.
So Steven, you were asking me.
Number 5 on the worksheet.
Number 5. So you're asking me where on.
Oh wait, no, this is the wrong worksheet.
Okay.
The molarity and titration.
So the other is Steven. You're gonna find. I'll post a link on Canvas on modules. When you hit that link, you'll be able to watch this office-hour video.
I sent him also the name of your YouTube channel along because I seen the videos too on there.
Right. So you're saying molarity. Where's that?
Right there.
Here. All right. Number what? 5.
Yes, please.
Sure. So how many moles of Na plus ions are present in 343 mLs of 1.27 molar solution of sodium sulfate? Okay. All right. So this is a question. We're going to find the moles of sodium in 343 mLs of 1.27 molar. What we are given is volume. It's 0.343 liters. We're given molarity, it's 1.27 molars, and this guy is actually sodium sulfate, Na2SO4. And it's asking us moles of Na+. So for volume and molarity, Steven, do you think you can find the moles from here? Moles of Na2SO4? Right, so you'll be able to find moles of Na2SO4, right?
And then you just
do mole-to-mole ratio. Yes, exactly. So if we start this problem, we start with volume first, right? Remember, we never start with molarity. We start with volume. And liters is here. Moles go up here. This is for Na2SO4. Moles is 1.27 moles in 1 liters, right? And then bottom here is moles of Na2SO4 to the moles of Na+.
And that you just getting
the mole-to-mole ratio.
Yeah.
So 1 Na2SO4 has 2 Na+, right? So when you solve the whole thing, you should get the answer. It says the answer is 0.871, so I'm just copying that from here. I think it should be that. If you do the math right. Let me just double check. So 0.343 times 1.27 times 2 is 0.87122. Yeah.
Okay, that makes a lot of sense.
Yeah. All right. Anything else, guys?
Can you go over? You said the problems that we went over in lecture on Wednesday are going to be on the exam as well, right?
Yes. You mean the charges, right? The oxidation states?
Yes. Can we do one of those?
Sure. So did you guys see this oxidation state worksheet that's also posted on Canvas?
No. Where is it at? On what module?
Same modules. There's this one module, right?
Okay.
So you go down to the Canvas. Then you go to your section. Then you go to modules. And then, so Steven, the other Steven, you were asking me where you're going to find it, the video?
No, that was,
yeah. Yeah, so you can find it here. This is where it's going to be posted on modules.
Okay.
And then you were asking me here, oxidation state under multiple choice worksheet, where you found everything else. That's where oxidation state is as well.
Okay.
All right.
It's under the molarity and titrations worksheet. Got it.
Right. So now you're going to find the oxidation state of all these things. So that there are some examples in the beginning, and then there are multiple choice questions, very similar to what you're going to see on the exam. So I'll highly recommend you guys to do this. Yeah, so Stephen Fleming suggesting, yeah, that's actually very good. This, I used to watch this channel a lot.
Oh, you did?
Yes.
Yeah, he's
It's
great.
very, very helpful. Yeah. I mean, also the extent of videos that he has made. I mean, I can't imagine how much effort he has put in, because it takes a lot of effort to make YouTube videos.
Does he make money from that, you think?
I mean, just the views, I think.
Yeah, okay.
Yeah,
Well, you can make money by doing that. You just got to find the right. You got to have the right subscribers and the right amount of viewers. I have a
Yeah.
YouTube channel also, but
Right, it's
it's coming
the
along.
number of views that you'll get, but usually for education channels, you don't get that many views, but he does.
Yeah.
And that's a great thing. But because he has a lot of content that he has posted.
Yeah, it helps me with my calculus class a lot too.
Yes. For all the math and chemistry. I think he also posts biochemistry. Yeah. I mean, I think that's the only guy that I can find he has like all the topics covered. For Gen
Thank you, appreciate it.
Yeah. So yeah, you guys were asking me the oxidation state. Do you guys have a particular question?
Like what exactly? Like which one will we exactly like?
Like,
Can
let's
you
just
give
look
like
at this one. Oxidation number of P and H3PO4.
okay?
So can you guys find the oxidation state? By oxidation state, we mean we want to find the charge. So find the charge of, when you're practicing these, actually a good idea is to find the charge of each one, H, P, and O. So if you have H3PO4, can you find the charges of each one? Where should we start?
We'll split phosphate in half, right?
Right. You can separate out your H and PO4. That's one way to do it. Or you can individually work on the elements. Let me give you one example first. If you have, let's say, CO3 minus 2. Let's do this one first, okay? CO3 minus 2. Can you get the charge of C and O? So Nick, do you know where to start?
Well, wouldn't I look at the periodic table for the charges? Because I know
Yes.
oxygen's obviously -2.
Right, exactly. So you're going to start always from the right-hand side, okay?
Okay.
So -2 times 3 is -6.
Right.
So what will be the charge here?
8, positive 8.
Think again.
+6.
Positive, if there was +6 -6, this number on the top should be 0. It's not, it's -2.
Right.
Negative side is winning, so tell me what will be the positive side? If I make this +8, +8 minus 6 is actually +2, not -2.
Oh.
Yeah.
So it's going to be 4.
+4, yeah. So carbon is +4, oxygen -2. Now, if you can't do this in your head, do this way. Assume that carbon is X, okay? Carbon charge is X. Plus the charge on the right-hand side, which is -6, is equal to the charge on the top, -2. So guys, the idea is charge on this side plus the charge on this side should be equal to the charge on the top, right? So
it's just basically algebra in a way,
right? And that also very simple algebra, the easiest form of algebra. So X is +4. All right, you guys got that example?
Yeah.
All right, so if you have H3PO4, you can basically do it two ways. I'm going to teach you both the ways, okay? If I have H3PO4, what I can do is actually I can split it into the H3 on one side, and then I have PO4 -3 on one side, right? I just took it apart. And of course, it's not going to be 3 anymore. But if you split this guy, it becomes this, right? H3 and then PO4 -3.
Mm-hmm.
Or actually, if I want to write this correctly, I mean, this is totally
H
correct.
plus, right?
Yeah, that's what I mean. This will give me 3H plus. That's actually what it's going to break into. H3PO4 will break into 3H plus and then PO4 -3.
Mm-hmm.
So if you have PO4 -3, and then we're going to find the charge of P and O, we're going to do it the same way we did the last one. We'll split this into half. Oxygen is -2 times 4, -8. So this side should be what then?
8 plus 8. Or no, I'm sorry. +5.
+5. Nick, are we getting why it's +5?
You just have to do the algebra since I'm not
Algebra.
doing it.
Yes. You just have to do the algebra. So you get the +5. So answer here should be +5 in H3PO4. P should be +5. And if somebody asks you like all one, H is how much? Can you tell me H is how much? H is always +1, okay?
Yeah, okay.
Because you see PO4 was -3. Okay, let me show you here. In H3PO4, if you split this guy into half, or not even that. Let's just do it this way. If we have H3PO4, you guys know that PO4, the whole thing is -3, right? So what I can say is this whole thing is -3 on the right hand side. So left hand side must be +3. And 3 hydrogens are +3, so each one is how much?
1.
3/3, so 1. So hydrogen is +1. So hydrogen is +1. Phosphorus, we figured out it's +5. And then oxygen we know is -2. Don't put -8. It's the charge per atom, so -2.
Now you said hydrogen's always just going to be +1, right?
Yes, when it's with non-metals. When it's with anything, always for sure negative. The only time hydrogen, I'm not going to test you on that. Whenever, let's say you have zinc H2, okay?
Okay.
Hydrogen with a metal, zinc metal, that's when hydrogen will be negative. Because in front of metals, hydrogen become negative. In front of non-metals, hydrogen become positive. That's the thing with hydrogens. And you can also find this in the rules that I gave you guys on Wednesday.
Now, for this whole worksheet on oxidations, is there going to be a specific number that you want us to stop at since we haven't gone through it more in
We have
depth?
done the whole thing.
We've done the whole thing?
Yes.
Okay.
Also, the other question you're going to see is going to be related to this one. So let's look at this one also very, very quick. Since you got last 3 minutes. So which species is getting reduced in the following redox reaction? Zinc plus PT2 plus gives you PT and zinc 2 plus. So can you tell me who is getting reduced? The question is getting reduced. Let me copy this.
You just have to see which one is getting oxidized, right?
Oxides all reduced, so you gotta find their numbers, right? So can you guys tell me what is the charge on zinc? This zinc sitting right here. Do we know the charge of this?
+2, right?
No. So look here. What is the charge on the zinc?
It's just 0.
It's 0, yes.
It's 0. Yeah, that's right.
Any element by itself is 0.
Oh, yeah, you were saying that in class. Oh, man, I forgot about that.
Okay. So, and then, what's the charge on PT?
Well, does it say it has a +2 charge right there?
Yes. Yeah, it's a +2. It says +2 here.
That's okay.
Yeah.
Yeah, zinc has no charge. PT is +2. What's the other PT on the right-hand side?
0.
0. What is this zinc?
+2.
+2. Okay. So what happened to zinc? Tell me. Zinc went from 0 to
+2.
So, and then PT2 plus went from PT2 plus to PT. What is that? What happened
0.
to this guy? Went to 0.
It went from 2 0. Yeah.
From +2 to 0. So what happened to this guy? Did this guy got reduced or oxidized?
Isn't it like the opposite of what it actually looks like? So that
No, it's not the opposite. It's the exact. It is what it actually is.
Okay.
So you see 2 plus to 0, the number reduced. So PT2 plus got reduced. So when the question says, you see, look at the options, okay? I mean, the options, of course, are incorrect. They should be A, B, C, D, not C, D, C, D. They're A, B, C, D, okay? So tell me what should be the right answer. So the question is asking which species is getting reduced out of these 4?
It's the second C.
It's this PT2 plus, right?
Yeah.
So your answer is going to be PT2 plus and not PT. So make sure you don't pick A as the right answer. It's not PT. It's PT2 plus who is getting reduced. Because PT2 plus went from 2 plus to 0. Does that make sense, guys?
So it's C, right? You said just C, right? C?
I said What do you mean Z? There's no Z.
C, I said C as in Charlie.
C.
Is the answer
Yes,
C?
Yes, C. PT2 plus is the answer, not the first C, the second C, okay?
So that's the chemical that's getting reduced, but it's also the oxidizing chemical. Is that where it's
Yes, so when it's opposite, exactly. So PT2 plus got reduced, so it is an oxidizing agent.
Okay. Okay,
Right.
that makes sense.
Yes. So when it's oxidizing, it's the reducing agent. The one who's getting reduced is the oxidizing agent. So that's where they're opposite.
And this question isn't asking us to name it; it's just telling us what happened, right?
Yeah, this one is just asking you whose number
Which
went
one
up, whose number went down. So look at the next question as well. I mean, it's the same reaction. Yeah, all these, I gotta edit these options. They're all messed up. So which species is oxidizing agent? Can you tell me now? We just did that.
It'd be C.
It'll be C, this PT2 plus. Because it got reduced. We just saw that in the last question. PT2 plus got reduced, so it is an oxidizing agent. What happened to Zn? Can you tell me, guys, what is going on with Zn? Zn went from Zn 0 to +2. So what will you say? Zn got what?
An oxidation.
Yes, it got oxidized. And it will be what agent?
Reducing agent.
Reducing agent.
Mm-hmm.
Okay. Let's see if there are more. Yeah. So look here. Tell me which one got oxidized. Who got oxidized?
Wasn't it zinc?
Yes, it's because zinc number went from 0 to +2, right?
Yeah.
So this Zn got oxidized. Again, make sure in the options, don't pick this C, okay? Because that's talking about this guy, this species.
Make sure it's the one with sulfur, right?
It's the one with S means solid.
Yeah,
So
solid.
this zinc. This is the same option.
Okay.
So pick that one.
You said you're going to give us a table that shows which ones are aqueous and solid and all that.
You won't need that in for this exam.
Okay, cool.
Hey, Amon, the rules that you gave us this weekend, what will we be using those? Like the rules like you gave us in lecture, the little worksheet you gave us?
Yeah, for this one, for these problems.
Really? Okay.
Yeah. So you can do this one, like MOO2. 5 MOO2. I'm sorry. MOO2. And you're going to tell me the charge of MO and O. Can you guys solve that?
Well, okay. You said the charge on O is always -2, right?
Yes.
So
Except when it's with fluorine. That's the only one who can win over oxygen.
Yeah.
So oxygen, so again, we're going to divide this, right?
Yeah.
Oxygen is -2 times 2, so -4. So MOS?
+4.
+4, right? So that's it, +4 and -2.
Okay.
If I give you this one, can you solve this? Give me charge of K, Mn, and O. Because I'll do this question for you, and then I'll ask you one more, okay? I'll teach you the way you can do this one. Let me close this. So we'll look at KMNO4, and we'll split it into 3 different elements, okay? We'll not do the polyatomic ion way. We'll just do it this way. So KMNO4, which ones, if you look at the rules that I gave you guys, or you can just think about it, for which ones the charges are fixed, K, Mn, or O?
Well, you said K and Mn both have 0, right? Because they're by themselves.
No, they're not by themselves. You see, K, Mn, O4, they're not by themselves. A K sitting by itself, that's by itself. Mn sitting by itself on its own, that's by itself. Oxygen sitting by itself, that's by its own. But when it's KMNO4, then they're not by themselves. So when you see KMNO4, guys, you know the oxygen, right? It's going to be negative 2 times 4, so negative 8. Right?
Yeah.
Okay, between K and Mn, for which one do you know the charge?
Potassium.
Potassium. What's the charge on potassium?
+1.
+1. So what should be charged on manganese?
+7.
+7, exactly. You guys see why? Because +1 +7 is +8, and there's negative 8, and that negates negative 8. So this total must be +8. So if this was +1, this must be +7. Does that make sense?
Right.
Mm-hmm.
Yeah.
Actually, I recommend you guys to do it this way. I think the polyatomic ion way is more confusing.
Okay.
This is more simpler. Okay, we'll do some more problems just to make sure we get this.
Now, a question though, Amon. Like in the last problem with the MO2, how come in that case it was +4, and on the other ones it was different answers?
What do you mean, different answers?
Like in this one, remember I told you in the last one when we were doing it right now, and you said that no, it's not +6, it's +5. With
What
the
example was
H3PO,
that?
like the one you're
Okay, let's do that one again, okay? So H3PO4, okay? We'll break it into individual atoms. Oxygen is again how much? -2 times 4, -8, right? Between H and P, let's start with hydrogen first. Guys, do you have that rule table with you right now?
I have it on me. I'm looking at it.
Okay, let me open that here just to quickly show you guys.
I'm looking at it actually right now. I have it in my hands.
So these are the rules, right, that I gave you guys?
Yeah.
Okay. You see in this rule, first of all, it talks about that oxidation numbers on the top should add up, right, to the total. Second rule says that the free elements have oxidation number of 0. Then the third rule then talks about group 1, group 2, and aluminum. They have +1, +2, +3, right?
Yeah.
And then it says H and F. H is +1 and F is -1 always. Hydrogen is +1 with non-metals, but it's -1 with the metals, like the example I showed you guys. Then it says oxygen is -2, except when it's peroxide. I don't test you on peroxide, so you can skip that. But O is -2. Then it says group 7 is -1, group 6 is -2, group 5 is -3. Now, you got to remember these in the order. Okay, what do I mean by that? If there's fight between group 7 and oxygen, oxygen is going to win. If there's fight between group 7 and group 6, group 7 is going to win. So rule number 6 comes before rule number 7, and that's why it gets the higher priority. Does that make sense?
Okay.
Okay. So when we talk about H3PO4, between H and P, who wins? So look here again, guys. H is mentioned here, right? In this rule number 4?
Yeah.
That H is going to be +1?
Yeah.
Where is phosphorus mentioned? What group is phosphorus?
5A.
5A. So where is that? It's the one at the end, right? So of course, who's the winner? Hydrogen?
Hydrogen, yeah.
Right? Okay. So which one should I write first? H or P?
H.
H. So H is what charge?
+1.
And there are 3 of them?
Oh.
Right?
Yeah.
So it's +3?
Yeah.
So H is this is +3, this is -8. So P should be what?
+5.
+5. And you can go back and double check that, the different method that we learned. H was +1, P was +5, O was -2. H is +1, P is +5, and O is -2.
Right.
Does that make sense?
Yeah.
It makes sense. I have a question on like the idea behind it on your last example. So you're saying that like there is one, so the oxidation state of potassium is the 1, but it also has 1+ electron.
It has 1+ electron. What do you mean?
Is that what you're saying? So like, because the question is asking the oxidation state, right? So we're finding out that the oxidation state of potassium is +1, and then manganese is +7, right?
Right.
Then, but for potassium, does that mean that it's just a coincidence that it also has +1 electron?
Yeah. So potassium, See, potassium is +1. It's type 1, remember? So +1 means it can lose 1 electron.
Yeah.
And it sticks with that because it also has a very high priority. If we look at that oxidation number chart, that metals is actually metals in group 1. Potassium is in group 1A. So it actually is over hydrogen, right? So potassium is always going to be +1, no matter who it's with. And it actually, +1 actually means that it lost 1 electron.
Okay.
And it was taken up probably by oxygen because that's the only one who is negative, you see. Manganese is +7, so manganese lost 7 electrons. Potassium lost 1 electron. And oxygen on the other side, 4 oxygens in total gained 8 electrons. Each one got 2 electrons.
Okay.
That's what actually happened, if you conceptually think about it.
Yeah.
That's why charge on the left-hand side should be equal to charge on the right-hand side. Because if 8 electrons were lost, somebody took those 8 electrons. Or you can think if somebody gained 8 electrons, somebody must have lost those 8 electrons.
Yeah.
Okay?
Okay.
All right, so let's do one more real quick, and then I'm going to end, okay?
Okay.
Tell me sodium, tell me chromium, tell me oxygen.
That's sodium dichromate, right, Amon?
Yeah, that's sodium dichromate. Okay. So guys, where should I start?
Oxygen?
Yeah, I mean, technically you can actually start with sodium as well, because you see, sodium comes with sodium is group 1. This is rule number 3, and oxygen is at rule number 5. So we can technically start with sodium as well. I mean, it's not going to hurt our answer.
Okay.
Right.
So +1 times 2 is +2. And then who should be our next one?
Then we should do oxygen.
Then we should do. Why do we not do chromium? Because you see, chromium is not even in the list. It's that far in the priority because it's transition metal, right?
Right.
It's not even in this rules. So of course it's going to be at the end. So oxygen is what charge?
-2.
And there are 7 of them.
So it's 14.
14. So this is what
Negative
charge?
14, that is.
Yeah. So this is what charge chromium?
Negative +12.
+12. Nick, is that right?
Yeah.
+12. Because +12 + 2 is +14.
Yes.
And this is -14, right?
Right.
Okay. So tell me what are the answers. What's the answer for sodium?
+2.
Okay. Think again, Nick. Is it +2 or is it +1?
+1.
+1. Because
of the rule. I forgot about the rule. I'm looking at the rule right now.
Yeah, the final answer that you put here has to be per atom. So don't solve the whole thing and at the end pick the right or wrong answer, okay?
Okay. Per atom. Okay.
Per atom. Tell me for chromium. Nick, you tell me.
Is it 12 or 13? I'm not too sure on that.
Yeah, see, what is the charge on Cr2? +12?
+12, yeah.
Okay, how many chromiums are giving you +12?
There's 2 of them.
So when I ask you per atom, what do you think is the charge? 2 chromiums have a +2 charge. +12 charge. 2 chromiums have a +12 charge. Each chromium should be how much then?
14?
No.
No, 12. Each chromium should be 12.
No. 2 of them are +12.
Right.
So 2 of them will be 12 divided by 2, which will be +6.
Okay.
Okay, does that make sense?
Yeah, so
Okay,
you
look here.
divide... Okay.
2 chromiums are giving you a 12 charge, okay?
Right.
That means each one is giving you +6. One chromium gives me +6, the other chromium gives me +6, and that's why the total is +12.
Oh, okay.
Okay? This is chromium 12. I mean, 2 chromiums have a +12 charge. So each one has to be +6. Okay? That makes sense?
Yeah.
So the final answer is +6 for chromium, okay? Not +12 or anything else. What about oxygen?
Yeah. Oxygen wouldn't still be it'd be a negative for sure. -2?
Negative.
Of course, always, because -2, right?
Yeah, why is it -2? Because you're again looking at per atom, right?
Right.
The per atom one, not the one which was for 7 oxygens. Okay?
Okay, per atom. All right, that makes sense.
You got that?
Yeah.
All right. Guys, if I ask you what is the oxidation state of copper in copper plus 2, what will be the answer? Yes, anyone can answer?
0.
No, think again.
+2.
Plus 2. See, copper plus 2 is copper plus 2. So you just copy paste that.
So if it doesn't have
If I ask
an
you
electron on
copper, and then see if this is the question, this is the answer. If the question says tell me the charge of copper in copper, the answer is 0.
But if it asks for the oxidation state.
No. I mean same. If it's giving you that Cu plus 2, it's giving you that it's plus 2. Then the oxidation state or ionic charge or the oxidation number, oxidation state, they're all the same thing, okay?
Okay.
So when the question is saying that copper is actually copper plus 2, then what is the charge of copper? It's plus 2.
Okay.
But if it says what is the charge of copper in copper, then it's 0. Because there is no charge.
Okay.
Okay?
Right.
So again, this is this rule here, rule number 2. Atoms of free elements have oxidation number of 0. So atoms of free element, this is free element. This is not a free element because it's saying it's copper plus 2. That means it has already given 2 electrons to somebody else. So it is not a free element. It actually means it's probably this. And they're only talking about this part.
Okay.
Okay. So we're just telling you that you should be able to understand that when it says it's just this, then of course the oxidation state of oxygen is 0 because there's no charge.
Oh, okay.
Because it's the same atom. That's why. Okay.
No matter what number is down there. So if it was like K4, it would be 0.
0. Yeah. K4. Each potassium is 0. Okay. But
so always for sodium, it'll be per atom. Same with chromium. You said right up there, right? Come on.
Yeah.
That's same with oxygen as well, right?
Yeah, that's true for all of them. It has to be per atom.
Okay.
So again, let me quickly finish this off, okay? So if I ask you, if the question says, what is the oxidation state of sodium in Na plus 1, what is the answer, guys, for sodium?
Na plus 1.
So what should I put here?
Plus 1.
Plus 1. The question is, what is the oxidation state of sodium in sodium? And the answer is, sodium is
0.
0. It's because you're just basically blindly just copy pasting this number on the top. But when I say, what is the oxidation state of sodium in sodium chloride, then what is the answer?
It would be plus 2, right?
Think again. Plus 2. Why would it be plus 2? See, when it's NaCl, that means that they should have charges, right?
1.
Yeah, wouldn't it be 1?
It'll be 1. So you guys just break this, right? What is the charge in chlorine?
It's -1.
-1. So sodium is plus 1. Sodium is in group 1, right, Steven?
Oh, okay.
Right.
Yeah.
So it can never be plus 2. You can never make sodium plus 2. So it's plus 1. You get that?
Yeah.
Yeah.
So look at these 3 examples. If you get this, you'll get the whole thing. If I ask you Na plus 1, what is the charge? It's this charge, plus 1. Copy paste that. What's the charge of sodium in sodium? No charge? No charge. But when I ask you, tell me the oxidation state of sodium in NaCl, then I want you guys to do work.
Okay.
The work is this. See, whenever you have your atoms as a compound, when they have somebody else, they will have a charge. When they're by themselves, they don't have a charge.
Okay.
That makes sense?
Mhm.
Okay. So +1 or -1. So of course, sodium is going to be +1. If I ask you the oxidation state of aluminum in AlCl3, can you solve that?
Well, aluminum is +3.
Never,
Yeah, it'd
never
be +3.
don't start with the positive guy. Start with the negative guy.
Okay,
make that a
chloride's
habit.
negative. Chloride's -1.
Times
3.
3.
+3.
So this is -3. So this must be +3, right? So aluminum is +3. So you got to do the work when you see the atoms with somebody else. Those are the ones where you have to put in the effort. Okay.
Cool.
All right. All right, guys. Is that good?
Yeah.
So I'll end this session and I'll post the recording for this one on YouTube. Okay, guys?
Okay, sounds good.
All right,
Thank you,
guys.
Amon. Have a
All
nice
right.
weekend.
All right. You too,
Thank
guys.
you.
Bye. Take care, guys. Bye.
See you tomorrow.
Right. See
Bye.
you.